Hello, everyone. This is Peter. Hi, Ravindra.
Hey, good morning, Peter. Hi, everybody.
Hi. How are you?
Good. How are you?
Good, good. I'm doing well. Thank you.
Thanks for joining.
Yeah.
I know it was not a very convenient time for you guys, but I appreciate the joining.
Oh, yes. Thank you. Hi, Barak. Thank you.
Hey, good morning.
Yes. Yeah, I'm on the East Coast, so it's not too bad for me, but it's okay for me. But our Taiwan team, it's a bit it's
Hmm.
Yeah,
almost 1 a.m.
I
Yeah, but
understand.
thank you for fitting us into the schedule. Appreciate it.
Sure, sure. Yeah.
Yeah.
Okay, let's give it a few more minutes for folks to join in, and then we'll get started.
Okay, great. Thanks. And I think we're going on this second half, right? There's the first half is the the wide area network
Right, right. That's
secure platform, right?
right.
Okay,
Maybe even shorter, I think.
okay. I did send the specification OCPs, the drafts for the OCP spec. There's about a total of 13 documents. I
Oh,
sent in a reply to the email that you sent.
nice. Okay. Let me take a look at that.
Sure. Okay. And I see we have Eric Chen, our R&D manager from Taiwan, already online, and
Mhm.
Louis from the West Coast, and Cheney from Taiwan is also online.
Right. Thank you guys for joining.
Hi, Ravindra. Thank you. Nice to see you.
Yeah, nice to meet you. Right, give me a couple more minutes.
So this meeting is once a month.
That's right. Yeah, it's once a month, second Monday of every month. So it's a fixed schedule, and then depending on the topics, we try to accommodate one or more.
Okay.
I believe Bharat is the person going to present the WAN router secure management. Is there anybody else that's working on the project joint already?
Do you see Bharat here already?
I don't see him.
Oh, all right.
Maybe,
Maybe you can switch.
yeah, maybe we can switch the order and then. So yeah, welcome guys. So we have two topics today. The first one we'll go ahead with is immersion optimized optical modules. It will be presented by folks from America.
Yes.
So Peter, I'll hand it off to you.
Okay, sure. Thank you. Thank you, Ravindra, Barak, and everyone. So we are presenting our draft proposal to OCP specification for optical transceivers, both for air standard air cooled application, as well as more importantly, more urgently, is the immersion transceivers. And for immersion, these are typically cableized and then sealed, and then make sure that the materials are compatible with the fluids. So we have about 20 minutes ago, I sent an email to, I think it's to the reflector that has the attachment of the draft proposals. Is there any particular orders that we need to go by, or it's we just go down the list?
Yeah,
Ravinder, did you see the email I sent?
I haven't seen it fully, but yeah, please go ahead. How much time do you need to cover them?
We can go spec by spec, or what's the typical sequence
Yeah,
because
typically we
it's
have a PowerPoint presentation that goes through various aspects of the specification. If you don't have that, then
yeah.
you can organize your flow so that it fits
Okay.
within
Okay.
20 minutes.
So yeah, so we actually dived right in and proposed the actual spec. So let me share my screen.
Right.
Sure.
Share. Okay. Are you seeing my screen?
It's coming. Yeah.
Yeah.
Okay. So this is the spec of the 400 gig QSFP form factor. SR4, that's 4 channels. Each channel of each lane is 100 gig per lane. And IAOP means immersion, active optical cable. So I guess my email has not arrived yet. This was sent at the 12:35, about 35, almost 40 minutes ago. It's a larger, it has 13 attachments, so maybe because of the size, it's taking longer. Is there a Google Doc place where we can deposit these that may be faster?
Yeah, we'll talk about there's a way to submit these specs on the portal.
Okay,
I would say right now, in interest of time, just review the contents.
sure,
But I don't
sure.
think we'll have time to go to 13 specs.
Yeah,
So
yeah.
you have to think about how to organize your presentation.
Right, right. So we follow the general, the OCP spec, there's a template, right? So we basically take the major template sections and then, whatever it's applicable to us, we kept those and fill in the information. So first licensing with the CLA. By the way, I filled out a CLA, a while back. It was never signed back. So we may need to take care of the CLA. But then the scope, we talk about this is for immersion product. And then the overview, it follows the IEEE standard for the 400 gig device, 400 gig SR4 device.
Peter, I think it will be interesting for the audience to understand what make this design unique for immersion cooling.
Oh, okay, okay, sure.
Probably that's
The
the heart of what we want to discuss, right?
Okay, so the heart of the what is unique about the immersion product is two things. One is, let me go to the, one is the material compatibility, that what you see, there's external and internal part. So overall, three things that need to happen. Number one is we have to make sure the material inside, outside are compatible with the various fluids on the market, whether they're single phase or two phase, whether they're hydrocarbons, fluorocarbons, esters, and so on and so forth. So there's for material compatibility testing, we follow the material guideline proposed by OCP back from November of 2022,
Mm-hmm.
right? Where it states the testing method, the 80 Celsius C, 0.8 liter, 336 hours, and then afterwards there are certain pass-fail criterias. So for material standpoint, that's what we use, both inside as well as outside of the transceiver. Outside of transceiver would be the cable, the boot, and then also the housing. Inside the transceiver, there are standard air products. We may use UV glue to fix the lens. We may use thermal pad to for conduction of the heat from the DSP chip and the laser driver and the laser to the housing. So inside the transceiver housing, there are also other materials that we had to adjust to make sure that they don't dissolve, they don't contaminate the fluid. So number one is material compatibility. Number two is how do we keep the integrity of the optical path so the fluid does not interfere with transmission quality, because the immersion fluid do not have the refractive index of 1, so it's different from air. So to preserve the integrity of the optical path, essentially we seal the optical engine either through potting or some sort of encapsulation. The specific methodology depends on the physical design of the optical engine. Typically, some of the multi-mode short-reach transceivers, they are VCSEL-based, but then the single mode for single mode transceivers, they may be using other lasers like DML, EML, or even silicon photonics, in which case the physical structure of the optical engines are different. So the sealing process of the transceiver optical engine portion is specific to that design of the optical engine. So first step is to make sure material doesn't dissolve, doesn't negatively impact the fluid. Second is we make sure the fluid and the photon don't come into contact with each other. So essentially the photonic path still traverse in air. So we basically preserve the air pocket in the optical engine. So the photon will operate, the transceiver will operate exactly as they would in the fluid, as if they were operating in an air environment. And then number three is to conduct bit error rate testing, transmit power testing, receiver sensitivity testing, as well as actual signal integrity testing for under the fluid to make sure that the signal quality is equivalent to air. I do have a PowerPoint. Give me a second. I will bring it up that I can share. So a lot of this makes more sense. Give me 1 second. Oh, I thought we were going to jump into detail of the specs and go through them. So okay, no, let's see. Okay, reshare.
Peter, I haven't received your email.
Yeah, it may be, is there a file size limitation? This was sent about over 40 minutes ago, and there's a 13 attachment. Each is close, 800. It's it's
I,
it's
I I think we'll follow up on these technical issues later on. Let's focus on the presentation at this point in
almost
time.
one meg per data per per attachment. Yeah. So yeah. So number one is we make sure that we follow the material compatibility testing condition. We've tested over a dozen fluid, more than a dozen actually. Just the suppliers close to a dozen, right? So BP Castro, Shell, ExxonMobil, Lubrizol, Aneos, Total, and Summer Engineering Fluid. We are in the process of getting fluid from Petronas as well as Oleon. So most of these are single-phase fluids. We have also been working with Chemours to get our transceiver immersion cable version tested in Chemours. And so far, that is looking very positive. They have finished testing individual materials. Key materials have been tested separately. And the next step is to test a whole product. The reason it's sequenced that way is if we start with testing a whole product, finished immersion cable, and it turns out that the fluid is contaminated, some incompatibility occurs, we have no idea which component contributed to that degradation, which material that degraded. So we typically test key components separately first. If that passes, then testing the finished immersion product should be a straightforward process. The signal integrity testing verification is what I mentioned, the TDAQ, the transmit power extinction ratio, bit error rate. Here is a list of some of the fluid that we are either have tested, completed, or in the process of testing. Sometimes because of fluid composition tweaking or our material tweaking, we need to repeat some tests. For example, the PERSTOR number 11, PERSTOR POE 390, which now they call SINMERS. This item is under that process, that retesting process, because of tweaking on either side. But overall, you can see for each fluid manufacturer, oftentimes they have different material, different more than one fluid, difference in viscosity, difference in flash point, that then we test multiple fluid from the same manufacturer. So just the manufacturer alone is quite substantial, and we are in the process of testing above and beyond the OCP guideline, 336 hours in the goal to support our goal of wanting to offer 3-year warranty, 5-year warranty based on the test results. We are anticipating that the materials will stand up to those number of years. Mean time between failure of a transceiver, standard transceiver for air, is very easily 70 years, 80 years, 90 years or above. So talking about offering a 3-year or 5-year warranty is not an issue, because the air transceiver is the base transceiver that we start with. And then for immersion, we add the steps I mentioned, which is typically the encapsulation or some sort of encapsulation process. There is testing wise, let me grab a different document. Okay. Want to highlight some of the testing we have done. Okay. Okay. So signal integrity, okay, this section is signal integrity. This is a typical topology where we submerge the eval board, the transceiver cable under test is plugged in, the whole setup is immersed in the target fluid. And then we have pattern generators, and then we have bit error rate detectors to see the data packet being sent, and then what is the output of the transceiver cable. So this test, the signal integrity test, we have already completed with BP and Shell, and there's ongoing additional fluids to conduct that. But at the 400 gig, and then we look at what was tested, the 400 gig, you can see the signal quality, TDAQ measurement, is very consistent between fluid and air. The red line on top, this is the maximum. the upper bound. Some parameters have upper bound only, some have upper and lower bound, like the optical transmit power. But you see the air is the base, and then we test the immersed version at the fluid temperature of 25 Celsius, then at the fluid temperature of 70. So at 25, whether it's air or immersion, you can see the characteristic track very, very closely to each other, because essentially the silicon, the laser, is performing at the same temperature. It's more sensitive to the temperature than whether it's in air or in immersion, because we see it very well. So now for transmit power for the 400 gig device, it's similar that at the 25 degrees, whether it's in air or immersion, they track very, very closely. And then at 70 degrees, you see a different line, separate line. But the overall is that there is well within the allowed upper and lower bound of measurement. This one is we're looking at the extinction ratio and then the bit error rate, right? So these parameters are all within the IEEE MSA specs, and specifically the bit error rate channel by channel comparison. You can see that they are all quite stable. There are some differences between different target fluids, but in general, they're all within specs. There's no outliers. There's no trending to be out of bound. So at the moment, we can comfortably and confidently say that at least up to 100 gig per channel device or below, immersion it's materially compatible. It is well sealed. And then the third is the performance is equal to performance in air
Peter,
or immersion products. Yes,
may I have a question?
yes, go ahead.
Can you please explain where the differences are? Like, why do we even see differences here? For example, if I look on the right-hand side, I see
Mhm.
about 2 decades, going from E-10 to E-12.
Okay.
What is driving these differences between the air and immersion? Because we said that it is already sealed, so photons will not go through the fluid.
Mhm.
So what drive these differences?
Right. So what's driving these differences is these may be from different modules, because we typically only put one immersion product in one fluid in tests. We don't soak them in different fluids. Does that make sense? So you're looking actually at different laser, actual physical laser in each
Oh,
module. There
I
is a
see.
spread of performance,
So it's
right?
not the same module, right? It's not that
It's
you.
not the same module, right? It's not the same module. Because when we do the immersion signal integrity test in immersion, we don't take the same, once you soak in one fluid, we don't contaminate that with other fluids, right?
Yeah. Oh, you say that it's the same design, but not the same specific part, or is it two different designs? I missed your point.
Same design, different part, different
I
serial number, right?
I see, but I think it's quite, at least per these charts, like the variance is always going, I think, against the immersion, if I read it correctly. So the
Say
performance
again?
of the air is consistently better.
Correct. You will see maybe 1 order to 2 order
Right.
difference,
Yes.
but even after that difference, with that difference, there's still a lot of headroom, because the thresholds 10 to the -4.
Yeah, I'm still trying to understand, like, what is the reason for it? Is it by chance happened in this particular test, or is there a fundamental reason for immersion to perform slightly not as good?
So far, that is what we have been observing.
Mm-hmm.
We think, and then on the copper, what we think is this: we can seal the optical photon part, right? But remember there's still PC board and the traces. It's a multi-layer board, so some traces are embedded, but there's always top layer trace. And the signal integrity workstream testing have shown that when it's called, I think, strip line, right? When it's strip line and the fluid comes in direct contact with the trace, due to the decay difference, the DF difference, the loss tangent difference, all that you do get even on the copper portion, the electrical portion of the transceiver, you see some difference. So this is, we think, is the cause of the slight variation between air and immersion. Not necessarily always because of the optical portion, but also on the, as if you take the transceiver as a whole,
I see.
you see some effect from the Goldfinger side, all the way to the PC board, right? And we can, when we encapsulate or seal, we can't seal the Goldfinger because we have to leave that for the connection with the socket, right? So we know that from the signal integrity workstream group that copper and the fluid, there will always be negative effect. And we think we only see a little bit because we only have the Goldfinger touching the come in contact with the fluid. If it were more, whether the difference would be more prominent or not, we're focusing on making a transceiver, so we haven't gone through that. Oh, just do additional that type of experiment. Yeah, but
Got it. Appreciate it.
Sure. Yeah, it's we were thinking, well, should we take the same physical part and just soak it in different fluid? We could, but you can see that we cannot guarantee we wash the inside, we clean the inside also. So you will get some fluid contamination. So we ultimately decided, like, look, even for air transceiver, we may be measuring, say, 13 or 200 parts or 50 or 200 parts, right? And you get that distribution. So we decided for immersion testing, we are using different parts, one part per fluid, one different part per fluid, right? So that's why you will see that some the bit error rate, because it's actually different laser, one laser per transceiver, but it's a different laser in each transceiver, right? So you get some spread of the laser distribution, performance distribution.
A quick time check. We're coming towards the half of the meeting, so if we
Okay.
could wind up, so we have one more topic to go through.
Sure. So back to the specification. This we just we covered the major sections, the form factor, the optical, the electrical characteristics, and then also from the below 100 up to 100 gig is DDMI, above 100 gig the management interface, the CMS, common management interface. So everything is spelled out, and then we refer to the reference documents that we use. We will add, I think we will add to this reference the material, OCP material guideline, which we use as part of the reference on how, yeah. So this is, these are there's 13 documents when the email goes through. It's better we get access to the portal and then put the file directly on the portal.
Yes, that makes sense.
I'm
Yeah.
dropping the link into the new contribution portal. So
Okay,
you can, if you have multiple specifications that you're submitting, create
Yes,
a
we
new
do.
one, create a new one for each one. But this will allow you to also sign the CLA directly within the workflow. And I can, since you've already presented to the project, what I can do is bypass the abstract piece, which is a new first step that we have, so that you can go directly to signing the CLA and uploading your documents for Ravindra and Bharat to take a look at.
Okay. Thank you, Alicia. Thank you very much.
Thank you.
Okay,
All
so the link to the new contribution. Okay, so we'll upload this to the files over there. Okay, great. Thank you.
Thank you, Peter. Appreciate the
So yeah,
presentation.
thank you for the chance. Yeah, okay. So after the draft spec is reviewed by OCP and approved, then the next step is to provide Formerica's product spec, right, to be reviewed by the committee and see if it matches, if it conforms to the OCP spec, then our product can be listed on the marketplace. Is that the correct sequence?
There will be an IC committee review, I understand, for the design specs for it to be approved.
Yes.
Yeah, I think Alicia
Just-
can walk you through this process.
Yeah, so once Ravindra and Barak, only one has to sign off from the project as the project leads, sign off on the specification as it is. They can make comments and any revisions, requests that they have directly within the workflow. And then once those are incorporated into this space and the SC rep signs off, then you're approved to go to the steering committee meeting and your presentation there. So for that presentation, I would recommend a more consolidated plan for a 15-minute presentation to the SC meeting, just kind of the high level expectations of what your designs offer and how they align with the OCP tenants. And then that then goes to them for review and vote. And once that's approved, then we can get it aligned with as a solution provider on the marketplace.
Okay, great.
Yep.
Thank
All
you.
right.
Thank you, everyone.
Thank you. Thank you. So yeah, we'll go on to the next topic we have on the agenda today. It's WAN router secure management spec. I'm not sure who's going to be presenting.
That'll be me, I think.
Yeah, Rob. Thank you.
Hi there. No problem. I prepared a few slides. I think hopefully you got a chance, or maybe we uploaded them in time, but I think we should have adequate time to go through them. This is a result of some work that a couple of my colleagues at Google, Anis, who's on the call, I think Subhashri couldn't make it, and then have been driving with some collaboration from a couple of our hyperscaler partners in both Microsoft and Meta. And really, it's changing tack from the previous presentation, completely in the software domain. So what the problem that we're trying to deal with in sort of in general terms is that there's no real common deployment specification for the routers that are being deployed in wide area networks. So we've got some things in the data center space that are being driven through open source or a few different mechanisms, but across the WAN space, there's a lot of fragmentation of solutions. And what this is leading to is incompatible pieces being delivered by different standards organizations that are starting to, that kind of get compiled into things that are implemented in particular products, which then don't turn out to actually be deployable for network operators. And so we've kind of found, like, if you try and glue some of the secure zero-touch provisioning things from the IETF into the wider ecosystem, there will be a bunch of gaps which require you to build a bunch of software or to try and glue different vendors together or different solutions together. And so what we wanted to do, it was to try and see if there was a way that we could initiate some collaboration across different folks that build these wide area networks to have a common set of requirements. And the goal was that having this, or the goal is that having this common set of requirements also helps on the implementation side, because we can reduce the kind of confusion and the challenges of building an overall product. And our goal is to do this across all the areas that we think the kind of software APIs into WAN routers. But obviously, this is an extremely broad area. There's many different ways that we're interfacing with these devices. So the goal is to break these specifications down into specific use cases. And the first of these specific use cases is this secure management problem. And so what we mean by secure management is being able to take a factory fresh router from out of the box or in a rack, and being able to take it through the process of securely reaching a minimum manageable state. And so that has a bunch of different things that I'll talk to that need to be specified in that. And once that device is at that minimum manageable state, managing these sort of ongoing security artifacts and the credentials that are on these devices. So today, there's not really a common way, a common spec that's being used for how to do this. There's different initiatives across different parts of the industry. So this spec tries to take that kind of overall use case and kind of walk through end to end how this could work. In the specification document that we uploaded a draft of, what we've tried to do is think about the summary of the threats that we're trying to mitigate through some of these solutions that we're proposing. So these need to mitigate things like the device that you received has either been tampered with or was a counterfeit device. The software that was loaded on it or is trying to be loaded onto it isn't genuine software written by the party that you expect it to be written by, so some form of counterfeit operating system or backdoor operating system. Unauthorized API access, so how do we, just for the APIs that is exposed, how do we manage think about how you can access those, and then alongside access to them, limiting privileges inside of those APIs. So we only allow users to do what it is that they're actually intended to by our security policy. And so the specification then walks through these different mechanisms or these different sort of operational use cases. We're really structuring around things the operator tries to do, and defines some things that are sort of cherry-picked from various parts of the industry as an overall solution. So for secure device turn-up, there's some device features that we're defining as a common requirement. Modified DHCP that gives you a way to be able to provide to the device, here's where you should go and talk to, here's where you go and connect to retrieve your artifacts, and then some open config specifications that go from providing the initial artifacts to be able to boot that device, things like the initial security certificates that it would need an initial configuration, through attestation, which is what we're calling the process of verifying that that device meets, from a software and a hardware perspective, the relevant, it meets the criteria of being genuine that we define based on a bunch of cryptographic cryptographic challenges that really center around the TPM on the device. And that overall set of open config features goes from the device being booted to the device kind of being in that secure manageable state. Alongside those device features, one of the things that you need the vendor to provide of the device is a way to be able to get an ownership voucher, which is a concept from the IETF around what are the public keys that you expect to see on that TPM and for this particular serial number. So you need some way to be able to say, I have this serial number, please can you give me the relevant security material as the authorized party that purchased it from you. So we have this secure device turn-up section. It lays out the requirements both for these device features and the endpoints. Then once this device is in this kind of minimum manageable state, we have a separate section of the specification that's talking about how we're doing certificate installation and rotation of that. So that's being able to provide the relevant CA chain, trust bundles, and the private and public key to the device, as well as any certificates that it needs for you to be able to assert its MTLS identity. And then on top of that, the AAA parts. So this is how we're thinking about doing authorization, limiting of specific access, and accounting of that. On top of the software requirements I talked to, there's some, for this secure turn-up spec, there are some hardware requirements. We require a hardware root of trust that's on a device that meets a specific set of TSG requirements for the TPM, so there's a TPM2 specification. And so really you can kind of think of this specification really as trying to pull together a set of bits from around the industry to say this is what the requirements are. And as a network operator, this is good because it lets you go and build against the API expectation and be able to have multiple vendors have a solution. As a network equipment manufacturer or software implementer, you can look at this and say, okay, we'll build those things and then it will meet the requirements for the subset of customers, or at least the subset of customers that we've written a specification for. And observation is that, you know, this is a bit of a snowball effect. The more it's there and works, the more customers use it. So having a common specification is quite powerful in that regard. We think that this contribution is in line with the tenets that we have. We've really been driving to do this as a cross-contributor development of the requirements. So really working with the partners that we mentioned and looking for other folks who are interested, some of whom are not OCP members. British Telecom, for example, trying to make sure that we've got their requirements, so we can really say that this does reflect not just the kind of hyperscaler requirements, but also the requirements across the industry. And we've been building on top of open SDO or open source specifications. So a lot of the spec here is building on OpenConfig, which is an open source project and has been for the last decade or so. As I said, there's kind of the efficiency gains of being able to have common requirements, avoiding duplication of both specification exercises, but also the development of these things. We want to try and avoid there being the need for developers and for network operators to be able to need to develop multiple solutions, and really also to allow operators to have multiple vendors, which is a requirement that I think most of the most large ones that we're aware of have. This area is like, we started with security. One of the reasons that we found is this area is fairly nascent. Doing this kind of secure device turn up is not something that's been kind of normal practice for some of these WAN operators, but you need just read the news, and security need to see places where this kind of critical infrastructure is definitely needing a step forward in its security. So this is why we kind of looked at this. And we're really thinking about how this works across, not just, you know, you've got a 10,000 of these devices to turn up, as it should also work down the kind of scale up and scale down type approach. And our goal is to promote use of existing technology wherever we can, trying to avoid anything kind of new unless it is absolutely needed. Ravindra.
Yeah, thank you, Rob, for the presentation and the contribution. I have a question regarding are there any test suites that you're planning to publish in the open source that would ensure or at least examine if a platform complies to these specifications?
Yeah, so that's actually is actually one of the core parts, I think, of this. We built an open source test framework, which is actually in use in Sonic as well as in a few network operators that's open source, and a set of compliance test suites. We've been at the evolve APIs to network devices for quite a while, and I would say the biggest mistake we made was not doing the compliance testing earlier. So for this, what we've been doing is essentially we've built test suites that cover most of these APIs already, and they're open and can be contributed by anybody and run by anybody using completely open source runner and infrastructure.
Oh, that's great. I mean, if you could share the links to those where that collaboration happens, that'll help the community to contribute and adopt.
Yeah, absolutely. It's in the specification. It's all Apache 2 license contributions on GitHub.
Thank you.
So I had just one more slide. So we're kind of starting at this root to security area, just to give you folks a kind of roadmap of where we're thinking we want to kind of take this effort. We'd really like to kind of partner and work with the OCP to be able to do this across different domains. We're starting with security. We think there's then a next set of things around software management on devices. So OS upgrade, firmware installation, optic firmware installation, and then third-party applications, container management. And then we have a set of other things where we think it can be expanded, but we haven't, as a group, spent much time talking about them in the control plane APIs, the management plane APIs, where we've got some things that are sort of de facto standards, but in a similar way, we'd like to be able to say this, you know, a common set of requirements across these operators to kind of encode those set of bits that need to be used together, and then test and qualification more generally. So whilst there'll be compliance suites along the way, we think there's some opportunity to be able to better kind of define, like, this is how we would like these kind of these kind of infrastructure and these kind of devices should be tested and qualified, which might have some hardware parts. Yes, so that was all I had. Any questions? I'm happy to answer.
I think there is a question on the chat. Just
I saw it come by and then
yeah, it just came in now, so that's totally fine. I can try help here. So the question is this spec public? If so, is there a link to the spec?
I uploaded it to the OCP portal. I don't think that makes it public yet, but I'm happy to publish it. I think that's just a case of how do we follow the right process inside OCP. The subspecs for all of these different features are open specifications. Happy to provide a link.
All right. Any other questions from the audience? Live questions?
Yes, this similarly to the for America specifications. So Rob has uploaded the specification documents to the new contribution portal site already. And then once it's reviewed and approved by Ravindra and Barak and the SC rep, it will then go to the next steering committee. And once that has been, the final specification has been approved, it will be uploaded to the contribution database for everybody to review.
I think, Alicia, my take on the question that's being asked is potentially people beyond like Ravindra and myself may want to further review it and potentially collaborate on and progress this spec together. So I'm trying to kind of think out loud here what could be a good process for that. And Robert, please chime in if needed. At least that's the way I read your question.
I think probably a few people where I work would be interested in taking a look at it. But we'll follow the process if it requires us to take a look at it after it's been approved internally. But either way, I know a few people who will be interested.
I mean, I'm happy to share, if that's okay, I'm happy to share the Google Doc link so that you guys can review ahead of time. And
exactly.
I don't think there's any, like, there's enthusiasm on our behalf to involve more folks. We just started it as a sort of discussion with some of our other peers, but there's no reason it needs to be secret.
The more collaboration, the better.
Yeah, absolutely.
Can you please put the link to the repository where you have all these files?
Yeah, so the spec is in a Google Doc, but I can also I'll make sure that it's got that in the indexes of it. It's got it's got all the links. And Alicia, would you be able to help me share with the folks on the call? I probably don't have the contact.
Exactly.
I'll have to take a look and see how we share within, because the workflow is kind of walks through the approval processes. So let me take a look and see how we can, because we introducing people who aren't actively contributing within the workflow could be a little bit problematic. So I just need to take a look at seeing how the best way to get that fit. It's a new process. We just started using it literally last month. So.
Yeah, maybe we should think about some kind of an ad hoc sub project or something like that.
Mm-hmm. Yeah, I think that would be good.
I just received a Peter email with many specifications.
But I think we don't want to make it a one directional process, right? I think what I hear, and Rob, let me know if it aligns with your view, is that in this particular case, at least, since by nature it's kind of a collaboration across many entities, probably we want to form a more comprehensive process to kind of share thoughts, ideas, and feedback.
Maybe, yeah, I think maybe we could create a workflow for specifications that allows additional people to be contributed outside of this workflow that is really just kind of taking it from submission to approval to reviewing the abstract by the top level project leads and the SC reps and then the SC committee. So
Yeah, because
so this
eventually, you
is
know, if Ravindra and or myself will review it, it will not be like a process of many other entities that may want to chime in and maybe not only review but suggest things to be considered for this specification and so on. Sorry, Ravindra.
Yeah, I mean, from the presentation, I observed that it's not a one-time contribution. There's more work streams coming up in the future. Then I would say we should consider spinning off a sub-project for this, that, you know, we can rope in more collaborators, have more regular collaboration meetings or wiki pages or email threads. OCP provides for such a
correct.
forum.
And
So
that's what we've done in the past too, is that sometimes we just submit and approve the initial specification, and then additional revisions and updates can involve other collaborators within the community. So maybe that would be our best first step for this one, since it is new to the community. And then going forward, we can spin off of it and have additional work streams.
That makes sense.
Yeah.
Yeah, the more the merrier from my perspective. So sounds great.
all right, we'll get back in touch with you on that.
So,
I really appreciate it. Thank you.
yeah, Ravindra, so you plan to have this as a work stream for the networking project?
I mean, yeah, if there is interest in a broader collaboration and there's more than one-time contribution, I think it's a sub-project is a good framework that we already have experience with running. So yeah, that's something we're going to put it out on the table.
Good. And this will be the OCS project or
No,
something else?
it'll be a new one.
New one. Okay. Thank you.
All right. Thanks a lot
Excellent.
for your time and presentation.
I think Ravindra, we also wanted to remind the team about the OCS mailing list, right?
That's true, yeah. Okay. Yeah, on that topic, OCS optical circuit switching sub-project has officially been spun off. It was similar to this one. Like 6 months ago, there was a presentation made by a company to open up the interfaces to optical circuit switches, SDN interfaces. And then since then, we've had interest from few other companies. And now it's officially a sub-project, and there's a page on the OCP portal, there's a wiki page, and they have their own calendar and meetings and mailing groups. So encourage folks who are interested in that to participate. And we hope to, this is just a good beginning of a long collaboration. Thanks, Brock, for reminding that.
Awesome. All right.
All right. Thanks a lot, everybody,
Excellent.
for participation and
Thank you, everybody.
Take care.
Thank you.
Thank you all so
Thank
much.
you.
Bye-bye.
Bye-bye.
It was a good one.